Hello, Assalamualaikum. My name is Muhammad FAISAL AFIQ BIN ZULHISHAM. I am from RY41. Today, I will continuing Lab 2, Operational Amplifier, Comparator and Summing Amplifier. So, comparator is usually used to compare the voltage amplitude and the output can bring out two steps related to the voltage in. So usually there is voltage reference is more from voltage in, or voltage reference is less than voltage in. So, for comparator, today we will be going to discuss about zero level detector and non-level detector. This is zero level detector and non-zero detector. So, for zero level detector, we go to the circuit here. So this is the circuit for zero level comparator. So whenever the voltage reaches to zero, the output is produced, which is amplifier, and it brings out new waves, which is the square waves here. So the value has increased from 10 volt to 13 volt. Actually it should be more, but because we are using the 50 volt, so the output is cut off less than 50 volt. So now let's go to the non-level 4.7 k ohm. Okay, for zero level we have to calculate the voltage reference first. Here 4.7 kilo ohm. Then like here for 4.7 kilo ohm, we have reference of 10 ohm. After calculating using the formula given, that is the V reference given. So R2 is 1 ohm and RY is 4.7 k ohm. We time with VCC positive, which is 50 volt. Okay. Now, so we get for Vref 4.7 is 2.63 volt. Now we go to the mati scene again. After I did the simulation, so we got whenever the voltage reference, so I got is 2.73. Whenever it reaches here, we can see the square wave from positive maximum to negative maximum. Positive 50 volt, so here at bottom is 50 volt also. Now let's go to non-level for 2 kilo ohm R1. It is 2 kilo ohm R1. So at 2 kilo ohm R1, after we calculate, we get 5 volt. Here 2 kilo ohm, we get 5 volt. So non-level, there is a rule for Vref is more than Vin. The voltage will become positive. Whenever the Vin is more than reference, it become positive maximum. Below become negative maximum. So for non-level 2K, is the same case for this one. Since we got 5 volt for V reference, it will never go more than 5 volt because we only put 5 volt. We only put 5 volt of the voltage input. So the output is stuck at 15 volt because that is maximum for negative output for our circuit. So it will stay here. For circuit 1 kilo ohm for R1, we change here. The circuit we still get the same wave and graph because the circuit cannot go beyond 7.5. It will stay at negative maximum until we change the V source here. Now for summing amplifier, it can add the the 2 voltage source, which that is called summing. It's adding up the voltage of the amplifier and of the source. So we have 2 source, 1 volt and 1 volt. We have 2 type of summing amplifier, which is the one is unity gain, whereas the resistor here for unity gain we change to R1 is 10k, and for R2 10 kilo ohm, and also R3 10 kilo ohm, and for R2 is the RF. Okay, now this is the circuit I built. This is the calculation I did and what I got from experiment. So the question, what do you understand about summing amplifier? The summing amplifier is another type of operational amplifier circuit configuration that is used to combine the voltage present on 2 or more input into a single output. And what happens to the output if the frequency of the source is increased to 3 kHz? The output voltage still remain the same. The only change is the time. So when the frequency increase to 3 kHz, the time taken to complete for one cycle decrease. Okay, for discussion A and B, during the experiment for the zero level detector, as input waveform is above 0 volt, the output will go to maximum voltage. So the output will form a square wave. For the non-zero level detection, the output form a maximum voltage square wave when the input reach to a certain voltage. The voltage is called V reference. So when the V reference is larger, the output square wave will be smaller. Okay, now let's go to conclusion. At the end of the experiment, I have learned and fully understand the comparator and the summing amplifier circuit. I also able to demonstrate the experiment using a software program artistic. Okay, thank you for hearing me, and thank you for lending your ear to see and hear my presentation. Thank you.